Coming into the part 3 of the assignment from same group number 162, where myself, Ram Kumar and Yatinder Kumar Tripathi worked on this assignment. The part 3 expects us to simulate movement of customers around a mall in a real-time fashion. So location data comes in the form of latitude and longitude. We need to understand who they are. Primarily this data probably coming from their cell phones, where the location data is being transmitted from. So the simulation it goes as follows. So what we are trying to do here, again the expectation is to simulate movement in a mall, for which we chose something like the Bangalore International Airport. The airport itself can be treated like a mall with a lot of restaurants. There is a launch, so the launch in question probably, or that is our, or we are the airport launch who want to target people, attract them into this launch for check-in. That is the purpose of this exercise. Let's assume this way. So we are generating location data of people around the Bangalore International Airport. The data can be from anywhere, but for the sake of this exercise, we are generating location data for about 1000. So the customer ID is a random integer between 1 and 1000. The latitude and longitude is a range of longitude and latitude range from around this area in the airport. So that's been executed using this code. So this is a code which runs forever until it is stopped. So we are generating random combinations of customer ID, latitude, longitude, and the timestamp at which it is created, and then it is pushed into a JSON format. For this use case to work, and also the part 4 to work, we are using a Kafka producer who is creating these or who is collecting this longitude latitude data and pushing it into Kafka. So that is what is being implemented here. So we used Kafka producer instance here, and the Kafka instance is set up on a separate system which is on a Raspberry Pi here. So the Kafka uses the topic by name customer underscore location, which is seen here. So this is the topic on which these JSON messages are pushed. So as you can see, again let me try running the code so that it shows the real-time execution of the code, which is creating these combinations of customer IDs, latitude and longitude, which is getting pushed into Kafka. So as you can see, these are the combinations of customer IDs, latitude and longitude with timestamps getting pushed into Kafka. With that, let's move into the part 4 of the assignment, where the expectation is to build a data pipeline which consumes this data from Kafka, of course, and then use this data to create a customized business logic, create an offer for people. Again, coming into the problem here, so there are data coming from all around this airport launch, but when the person is closer to the airport launch, we want to target them with a personalized message, which is implemented in this code in part 4. Let me run that again as well. So starting with the Kafka consumer here, which is connecting to the Kafka instance, pulling out messages. It is detailed represented in this file here, but what we are doing is trying to get all the messages from Kafka, process it, and find customers who are closer to the business launch and create a customized message for them. So here it's implemented the same way. So Kafka is running on this server, which is shown otherwise. We are getting all the messages real time, and then there is a point of interest already defined, which is the business launch here. So the latitude and longitude is known for that business launch. We are calculating the distance between the user location and the point of interest here, and if it is within a threshold, so the threshold maintained as 0.001, if the distance threshold is coming within that, we are generating a personalized offer for that user. Ideally, this offer should be pushed back into the user's mobile app, which is not implemented for this demo purpose, but a customized message including the customer ID is shown for a representation purpose. In real world, we would use that information, use other metadata for the user, and then create a personalized message. Just as you see, the customer ID is used in the personalized offer, which is shown here as an output, but it in a real world will get pushed into either a mobile push notification, in most cases that is the case, or an email and things like that. So as you can see, the Kafka distance measures are calculated real time, we can see it. So as the new entries come, they get consumed here, the distances are calculated, and once they qualify for an offer, which is getting closer to the business launch, which happened in some of these cases, as you can see. So for example, customer ID 724, Bengaluru Airport launch welcomes you. Enjoy a free drink when you present this message when you check in. So this is a personalized message which is created using the context. We could use other metadata as available here. We only have the customer ID, for example. And as you see, there are users getting qualified for this offer and messages are being generated. So this is the whole assignment. Thank you.